I know that some of you could not see the screen, some of you could not hear very well. So what I'm doing now in this video is I'm going over the questions that we went over in the second part of the period. I expect you to have watched the video on angles of elevation and depression, and here are the questions from exercise 12b. So in this question, we see that a 5-meter ladder reaches 4.2 meters up a wall. So to think about this, we can sketch. There is a horizontal ground, and here is the wall. Obviously, the wall makes a right angle with the floor. The ladder usually leans against the wall in this way. And it tells us that the ladder is 5 meters long, so this is the 5 meters. And it reaches 4.2 meters up the wall. So this distance from here to here is 4.2 meters. So what is the angle that the ladder makes with the wall? So we're looking for this angle, and let's call it theta. So as you can see, we have a right angle triangle, and if we want to make the sketch a bit easier, our triangle looks like so. This is 5 meters, this is 4.2 meters, this is the right angle, and that's the angle we want to find out. So as far as theta is concerned, the 4.2 is the adjacent, the 5 is the hypotenuse, and the trigonometric ratio that connects them both is the cosine. So cosine theta is equal to 4.2 divided by 5. Therefore, theta equals cosine inverse of 4.2 divided by 5. I'm going to do this on the calculator, and the rest of the calculator work, I'll leave it to you. Shift cosine of 4.2 divided by 5, and this is 32.9, 3 significant figures. So this is the angle that the ladder makes with the wall. So as you can see, the problem is really requires understanding and a nice sketch, a nice clear sketch. Then we discussed question 3. The angle of elevation from a rowboat, so we're talking about the sea now, to the top of a lighthouse that is 25 meters above sea level is 6 degrees. So what we have is the sea, and right on the shore we have a lighthouse. There is a rowboat somewhere, so let's say it's here, and the angle of elevation from the rowboat to the top of the lighthouse is 6 degrees. So this is 6 degrees, and the lighthouse is 25 meters above sea level, so the height of the lighthouse is 25 meters. And we want to calculate the horizontal distance from the boat to the lighthouse. So we're looking for this distance. Now, as far as the 6 is concerned, the 25 meters, the height of the lighthouse, is the opposite, and the distance that we are required to find, let's call it x, is the adjacent, because the lighthouse is a structure that is vertical to the ground. So in this case, opposite and adjacent give us tan, so tan 6 is equal to 25 over x, and you're required to solve for x. You can do that on your own. Now this is an interesting question, and it requires a bit of understanding before we begin. A train traveling up an incline of 4 degrees travels a horizontal distance of 4 kilometers. How much altitude has the train gained? We can understand the question by appreciating that motion sometimes is made up of two components, i.e. two parts. Imagine that you're here and you move along the horizontal for a certain distance and then along the vertical. So you end up here. This effectively means that you have moved along this red line. Those two, the horizontal and the vertical, are components of this part of the journey, the red line. So it's a nice word to understand, component. We are basically saying that the sum of those two parts of the journey is this red part of the journey. Because instead of going this way and that way, you can directly go from here to here. So what we have is an incline of 4 degrees. So there's like a ramp and the angle is 4 degrees. The train travels a horizontal distance. Now the train is going up the red line, but horizontally, the horizontal component of this journey is 4 kilometers. What we're required to find is how much altitude. Altitude is another word for height. How has the train gained? In the sense that how much higher is the train at this point than it is at this point. So basically, that means finding the vertical part of the journey. Again, as far as the 4 is concerned, x is the opposite, the 4 kilometers is the adjacent, and tan 4 degrees is equal to the opposite divided by the adjacent. And x equals 4 times tan 4 degrees. And you can work this out. And this question about the goalpost requires us to understand what kind of goal we're talking about. It's like a goalpost is like a column. So it's like having a column that snaps somewhere here, that breaks, and this part folds. So we are not talking about a football goalpost. We're talking about a rugby goalpost, like a column, and this part has fallen down to become a hypotenuse of a triangle. So the idea here is that you want to find the height of the post before it snapped. The height of the post before it snapped, well, the post was this part, and this part was erect on top of it. So let's call this x, and let's call this y, and in this case, the height of the post is x plus y. So consider finding x first. This is the opposite, and the 15 is the adjacent. So tan 25 is equal to x over 15. You find x. And then for y, the 15 is the adjacent, but the y is the hypotenuse, and the ratio is the cosine. So cosine 25 is equal to 15 over y. This gives us x, you can evaluate that, and this gives us y, you can evaluate that, and then you add the two together to give you the height of the post. And finally, we have to remind ourselves of the properties of quadrilaterals. Here we have a rhombus, and the rhombus is a quadrilateral with 4 equal sides. It's a parallelogram. It might be a square. The square is a special case of a rhombus, but it might not be. So we work with the general case. So this is 10 centimeters, this is 10 centimeters, this is 10, and this is 10. We also know from our work at the beginning of the unit that the diagonals of the rhombus bisect each other at right angles. So we have this side is equal to this side, half, and this half diagonal is equal to this half diagonal, and that we have a right angle here. Now, the angle between the two adjacent sides is 76, so this is an angle of 76 degrees. We are required to find the length of the longer diagonal of the rhombus. Obviously, the longer diagonal is this. It cannot be the blue, because the blue is opposite the 76, but this angle is obtuse, so it must subtend the longer diagonal. So we really need to do one little trick to understand this, to appreciate this problem. If we take this part away like so, we have an isosceles triangle. And if we have an isosceles triangle, then the perpendicular from the vertex to the base bisects the base, so this is really part of the diagonal, and more importantly, it bisects the vertex. So this angle here is half of the 76, which is 38 degrees, and this is 10 centimeters. Let's call this side D. D is the adjacent to the 38, and 10 is the hypotenuse. So therefore, we're talking about the cosine. So cosine of 38 is equal to the adjacent, which is D, divided by 10. And D is therefore equal to 10 cosine 38. Let's work this out. 10 cosine 38 is equal to 7.88 meters, or centimeters, I mean. 7.88 centimeters. But we have just remembered that the diagonals bisect each other. So if this part is 7.88, then this part is also 7.88. So the diagonal is twice 7.88, and it's the product of, and you get the answer and you know what this is. Okay? So that's the work that we did in our session today. I will send you more work on EduNation, but I expect you to finish the questions in exercise 12B by Thursday. And I'm really pleased that you have all attended the lesson this morning. I'm proud of you, and I think that we should show that this crisis is not stronger than we are. We are going to continue, and we're going to learn, and we're going to make use of our time. And I have full confidence in you.